Okay, we're back with our review for exam 2, and we're up to 3a. Now f of x here, we want to basically take derivatives using derivative rules. F of x is a quotient. So we could use the quotient rule, but the quotient rule really is more complicated than what we need. We could just use the power rule. If we divide everything in the numerator, each term, by x to the 1/2 square root, which is the same as the square root of x, then we'll be writing f of x as the sum of powers, and we can use the power rule. So that's really the preferred method because it's a simpler method. So let's do that. So we're going to rewrite f of x is equal to 3x to the 5th divided by x to the 1/2 minus 7x divided by x to the 1/2 plus 10 divided by x to the 1/2. Alright, so that's equal to 3x to the 5th, that's 10 over 2, minus 1 over 2, that's x to the 9/2, minus 7, x to the 1 minus a half, that's x to the 1/2, plus 10, x, bring this up, 10x to the minus 1/2. Alright, that's just f of x. Now we take the derivative. Bring down the 9/2, 3 times 9 is 27, 27 over 2, x to the 9/2 minus 2/2, that's 7/2 over here, minus 7 over 2, 7 times 1/2, 7 over 2, x to the 1/2 minus 1, that's minus a half, minus a half times 10, that's a minus 5, minus 5, x to the minus 1/2 minus 2/2, that's minus 3/2. So there we have it, that's f prime of x. Alright, let's go to the next function. Well, our next function is a product. Here we have the first factor in our product, and here's the second factor in our product. So we're going to use a product rule. So let's just do that right away. F prime of x is equal to, we'll do the first times the derivative of the second. Here's the first function, 3x plus 2 to the 10th, times the derivative of x squared plus 7x, that's 2x plus 7. Plus the derivative of the first, okay, here we need a chain rule. We're going to bring 10 down. Alright, here's the chain rule. 10, bring down that 10, 3x plus 2 to the 9th, and now multiply by the derivative of the inner function. The derivative of 3x plus 2 is 3. Alright, so that's just the derivative of the first function and times the second. The second is x squared plus 7x. Okay, we leave it like that. Okay, let's look at C. We have a quotient. Alright, so we're going to use the quotient rule. So first we start by squaring the denominator. That's 2x minus 3 squared, and that goes in the denominator. Then we write the denominator here, right on top. Okay, so the numerator starts with 2x minus 3 times the derivative of this top function. So we need to do a little chain rule there, bring down the 50. (5x plus 7) to the 49 times the derivative of the inner function, that's times 5. And now we have a subtraction. Okay, so now we have the derivative of the denominator. Well, that's just the derivative of 2x minus 3 is 2 times the upper function times 5x plus 7 to the 50, to the exponent 50. Okay, so that's the quotient rule. Alright, so let's continue here. Here we have, in number 4, we have an implicit differentiation. So let's look at that. Okay, so we have to find dy dx, and let me rewrite this. X y squared minus y x squared is equal to 2, and we're assuming that y depends on x. Alright, so we'll start with a product rule for xy squared. So we have the first times the derivative of y squared, that's times 2y dy dx. The first times the derivative of the second plus the derivative of x is 1 times the second times y squared. So all of this is the derivative of this first term, xy squared, minus the derivative of yx squared. So we have the first y times the derivative of the second times 2x plus the derivative of y, that's dy dx, times the second times x squared is equal to 0 for the derivative of 2. Okay, now we want to rearrange this. Well, first of all, we have to open the brackets here, and we're going to gather together the dy dx's. Okay, so this first term, let me write as 2xy dy dx plus y squared minus, now I'm into these brackets, minus 2xy, and then minus x squared dy dx equals 0. Okay, so that's just opening parentheses. Now what we're going to do is rearrange this. Let's factor out the dy dx, and in front of this dy dx we have 2xy minus x squared, and all of that is times dy dx equal, and on the other side of the equation we'll put everything that doesn't contain dy dx. We'll have a minus y squared when this is brought to the other side, and a plus 2xy when this is brought to the other side. Now divide by whatever is multiplying the dy dx. Alright, so we have dy dx is equal to the right hand side divided by what's multiplying dy dx on the left. Okay, so there we found dy dx in terms of x and y. Now we want to find the equation of the tangent line at point 1, 2. Okay. Equation of tangent line at point 1, 2. Alright, so first let's find dy dx, the slope at 1, 2. That'll give us the slope of our line, the slope of our tangent line. So just substitute the 1 for x and the 2 for y in this expression. Okay, so that's a 2 for y, that's a 1 for x and a 2 for y. Okay, a 1 for x, a 2 for y, minus a 1 for x. Okay, so let's see, what's that equal to? Okay, so in the numerator we have minus 4 plus 4, so that's 0. 0 in the numerator. And in the denominator, let's just make sure the denominator is not 0. Well, it's not. We have 4 minus 1, which is 3. Okay, so 0. That means we have a horizontal tangent line. Alright, and now the point is 1, 2. Y coordinate 2. Okay, so that means the equation of the line is just y equal 2. That's the form of the equation of a horizontal line, y equal to a number.